In this video, I want to show you how to perform a structural breakpoint analysis using the R package strucchange. Strucchange is mainly an R package for detecting, testing, and estimating structural breaks in linear regression models. A breakpoint is the estimated boundary value, a boundary where a regression relationship changes. For example, the intercept, slope, treatment effect, or mean can differ before versus after that point. Breakpoints, Y-tiered time ID estimates changes in the time trend regression, and breakpoints Y-tiered 1 detects mean level changes only. And the function F-stats and SC test assess evidence for a single structural break, while breakpoints can estimate and compare models with 0, 1, or multiple breakpoints. And BIC is commonly used to select the number of breakpoints, and breakpoints BP4 extracts the minimum BIC partition, balancing improved fit against the added complexity of more segments. So these are a brief introduction of the R package strucchange. And here breakpoints are a special type of change points, but they're specific to regression models. So in this video, I'm going to demonstrate how to use the R package strucchange to perform different tasks related to the structural change in a regression, linear regression model. And then you will see how to use this R package for different tasks. And then you will get this R script, which is written and tested here. So in the future, you're welcome to rerun the R codes, have a better understanding of the R package strucchange, and when you have your own data set, you are welcome to modify the R script to fit your own data analysis task. Okay, thank you, and let's get started. First, you need to install the package strucchange, which is very straightforward. I already did that, so let me load in the package, and then we first simulate the data with a break after observation 100. Let's select today's data as the random seed. So n equal to 200 time ID equal to sequence length of 200. And then we generate the Y, which is follow this formula, 2 plus 0.5 times time ID from 1 to 100, plus a normal random noise. And then you have 10 plus 0.2 times time ID 101 to 200 plus another normal random error. And then put them into a data frame, and you can use plot to generate what on the right side simulate a series with structural break observations from 1 to 200. You can obviously see there's a break at observation 100. All right, so let's start to use the R package strucchange. Test for parameter instability using OLS and cumulative sum, okay, CUSUM. So you can use the function for the EFP. Okay, so the syntax is pretty simple. EFP, Y tier the time ID, data equal to that, type equal to OLS, CUSUM. Okay, and then once you fit it, you can plot it. It looks like that. Now the time becomes from 0 to 1.0. Okay, so you get around, I think, 0.5. You have a breakpoint over there from this OLS CUSUM test. Okay, and you can also print the SC test result. So if you want to do a hypothesis testing, you can see down there the p-value is rather small. So it is not really a coincidence for you to observe or detect that breakpoint. Okay. All right, and then you can use the super F or Chow type test for one break. Okay, so this is a test developed by Chow. So you have like the super F statistic. You use the function F-stats and Y tier the time ID, they take the that, and then put them into FS. You can plot out FS, give it a title F-statistic for candidate breakpoint dates. You can look at, still use now, convert the time from 0 to 1, and you can see the peak for the F statistics is around 0.5 there. Okay, so you can again print it out the SCT test result. Also has a very small p-value indicating its statistical significance. Then display break implied by the maximum F statistic. You can plot the time ID and put the vertical line there. Connect all the lines, the break, look like that, right? So this is the F statistic implied break over there. Okay. And then you can estimate 0 through 5 breaks, then choose the minimum BIC model. So if you're not sure about how many breakpoints are there, you can get a range of number of breakpoints, and you can run through all the possible number of points, and then look at the BIC value. Okay, so you can use breakpoints, the function breakpoints, Y tier the time ID, data to the dat, and breaks equal to 5. Okay, so this is say you're gonna try breakpoints from 0 to 1 to 3 to 4 to 5, and then you put them into BP4. The default is extract the minimum BIC partition, so you get the extract the breakpoints from the BP4, and then you extract some of the estimated breaks, and then you can print BIC, select the number of breaks, and then estimate the break number points. And if number of breaks equal to 0, then just say none. Otherwise, paste BP breakpoints collapse equal to this dot, and then start. And then this would give you estimate breakpoint at 100. And if you want to see the summary of the BPF, you can see it printed out the bunch of output from here. M equal to 1 tells you where the breakpoint is, the 100. M equal to 2, it's at 100, and then 165. Etc. 5, 3, 4, 5. And then down there you have the RSS and you have the BIC. You want to look at the role of the BIC. You can see the first is 1392.7, and then goes down to 895.9, and it goes up to 903.8, and then goes up 190. 115.2, etc. So you can actually plot it out. You can see on the right hand side it goes down from 0 to 1, a huge drop, and then it just start to going up. Okay, so then number of change point Z1 has the lowest BIC value, so it supports that there's a 1 breakpoint. Okay. And after that, you can actually fit a segmented regression model. So if the n breaks is greater than 0, then you can do segment breakpoint BP break equal to n break, and then you do the fit linear model Y regress down seg and slash time ID, and everything else, then fit equal to Y regress LM Y regress time ID that equal to data. And then you can plot out the time ID look like that. And if n break is not 0, then add an AB line and put some legend there. You can see on the right-hand side, you plot out the data, raw data, and you fit the segmented regression. Those are the lines with a breakpoint at observation 100. Okay, so you have observed, segmented fit, and estimated break over there. And also optional, you can calculate confidence interval for the BIC select breaks. So if the n break greater than 0, then you can use the function conf int of BP for breaks equal to n breaks, and then print out the confidence interval is I think a percentile, so 2.5% and a 97.5%. So you get a 95% confidence interval for the breakpoint 0.5. All right, so I hope this is helpful for you to learn about the RPackage structure change for analyzing structural breakpoint in linear regression models. Thank you.